Hi everyone, thanks so much for joining. It's a pleasure to have you all here today. In today's webinar, we're going to be looking at data mining techniques. Some basic, a basic overview of what data mining is and a basic overview of the techniques. And we're going to be looking at these techniques specifically as they relate to customer relationship management. For nonprofits, typically, our customers are our either donors or the ones, or the clientele, or the clientele that we support. So we're going to be looking at data mining techniques for customer, like an overview of data mining techniques for customer relationship management. This is what we're going to be taking a look at. First of all, what is data mining? Next, we're going to look at what the motivation for data mining is. We'll take a look at a brief history of it as well, where it started from, how it progressed. Following that, we'll take a look at data mining applications. More specifically, what does data mining apply to? How is it applied in a day-to-day, on a day-to-day basis? Next, we're going to look at applications of data mining in customer relationship management. We're going to zero in of all the applications data mining is, of everything that data mining is applied to. We're going to zero in on how it's applied to customer relationship management. Next, we'll take a look at data mining taxonomy. And finally, we'll look at data mining techniques. So let's get started. Data mining. Data mining is the non-trivial extraction of novel, implicit, and actionable knowledge from large data sets. Right? Typically, a company will have a database of either all their clients or the products they sell. They'll have a large database of a lot of different information that's relevant. The question is, how do we translate how do we extract that information into practical knowledge? Now, we have extremely large databases. Data mining will help us discover the non-obvious. It'll provide us with useful knowledge that can improve processes. And it's used specifically for figuring out trends, patterns, and whatnot, things that can't be done manually. Now, it's basically a technology to enable data exploration, data analysis, and data visualization of extremely large databases at a high level of abstraction, without any specific hypothesis in mind. It'll provide us with sophisticated data search capabilities that basically use statistical algorithms to discover patterns and correlations in data. In other words, we don't necessarily know. For example, if we sold, let's say we have an ice cream shop, okay, and we sold two flavors. We sold strawberry and vanilla, okay, and we know we sold a lot of it, but we don't know necessarily why and to who. Data mining will help us search using statistical algorithms. It'll spit out patterns. Say on a hot day when the weather was 78 degrees, we sold X amount at X amount of this and this flavor of ice cream at this and this price. And it'll tell us, okay, so there's a specific correlation between the weather and this flavor of ice cream, or the weather and this price for this flavor of ice cream. Now, let's just take a look quickly at where it came from. Okay, where did it start from? Now, you see here the 6 components of data mining. we have a database going clockwise. We have a database. We have visualization of that visualization software. We have applied statistics. We have software that can apply statistics to specific data. We have pattern recognition, where we can recognize certain patterns. We have parallel algorithms. Then we have high-performance computers, and we have machine learning. Okay, all those 6 things contribute to the overall data mining. Now, really, the big picture is what's called knowledge discovery in databases, or KDD. Okay, that's the process that data mining, that's the big picture process that data mining fits into. Okay, now KDD consists of data warehousing. Right, that's where we're going to have we'll have a server that stores all the data of our company. It includes data selection, data pre-processing, data transformation. Then comes data mining, and then comes interpretation and evaluation. That's the big picture that data mining fits into. However, they are sometimes used synonymously. They are sometimes used synonymously. That's data mining and KDD. Sometimes data mining is sometimes referred to as KDD, and they tend to be used as synonymous. Now, let's take a look at a history of data mining. Let's start in the 1960s. We're going to be going across. Okay, we start, the 1960s, we had data collection. Okay, the typical business question that we take, the typical question we had that we'd want data mining to answer, let's say a random question is, what was my average total revenue over the last 5 years? So at that point, the enabling technologies we had were computers, tapes, and disks. The providers were IBM, CDC. The characteristics of the data mining at that time period were retrospective static data delivery. Okay, then we moved up to the 1980s. Okay, that was the stage where we had data access. The question we tried to answer was a drop, you'll notice a drop more sophisticated. What were unit sales in New England last March? Okay, so we're looking for the number of a specific unit sales in a specific geography in a specific time period. The enabling technologies at that point were relational databases, SQL, and ODBC. The providers at that point, you'll see the industry got a bit bigger, was Oracle, Sybase, Informix, IBM, and Microsoft. The characteristics of this data mining profile was retrospective dynamic data delivered at a record level. Okay, then we moved up in the 90s, we moved up to data navigation. Here, we were able to ask, here data mining would be able to answer, what were unit sales in New England last March? And then let's drill down to Boston. Okay, so here we're taking all the data, categorizing it by unit, by volume of unit, by geography, by specific time period, but we're able to drill down to a smaller geography or a smaller region within the larger region that we're mining. The technologies at that point that were available were online analytical processing. We had multidimensional databases and larger data warehouses. Here the product providers were Pilot, IRI, Arbor, Redbrick, and Evolutionary Technologies. Those were the companies that were providing that service at that time. The characteristics of that data mining profile: retrospective, dynamic data delivery at multiple levels. In other words, we have level 1 would be a large geography. Level 2 would be broken down into smaller geographies. Finally, in 2000, we advanced a bit, and we'd be able to use data mining to answer the question of what's likely to happen in Boston unit sales next month and why. Okay, so this is already moving from retrospective to prospective. We're able to forecast based on trends, based on, let's take a look at the enabled technologies. Okay, we had advanced algorithms, multiprocessor computers, and massive databases. So we were able to apply those advanced algorithms. We were able to apply those multiprocessing computers to the larger databases. And once they got more sophisticated, we're able to move from retrospective analytics to prospective analytics. Okay, the product providers at that point, the pioneers of this prospective data mining were Lockheed, IBM, SGI, and there were a lot of startups providing that service as well. And the characteristics of that profile of data mining, again, were prospective, proactive information delivery. We're able to forecast, we're able to project using these advanced algorithms and multiprocessing computers to give us the information to give us a forecast of what we'd be looking at. Now, data mining a lot of times gets confused with some other things. Let's just go through what it's not. Okay. Data mining is not data warehousing. It's not SQL, ad hoc queries and reporting. It's not a software agent. It's not an online analytical process. And it's not data visualization.